KHAB 17, HSE Global Safety Leader Professional Training Academy. Module 8, HSE Leadership, Site Coordination and Career Preparation. Section 3, Contractor and Visitor Safety Management. Learning Objective. By the end of this section, learners should be able to coordinate contractors, visitors, and multiple work groups safely, understand contractor control systems, manage permit interfaces, support SIMOPS coordination, and apply communication protocols consistent with NEBOSH IOSH ISO 45001 and API RP75 principles. Contractor and Visitor Safety Management. Modern construction, oil and gas, and petrochemical projects rarely operate with a single workforce. Instead, projects often involve main contractors, subcontractors, specialist vendors, inspectors, consultants, visitors, regulatory representatives, client personnel, equipment suppliers. Each group may have different procedures, different supervisors, different experience levels, and different safety cultures. This creates one of the most important responsibilities of HSE professionals: coordination. Many serious incidents occur not because individual work activities are unsafe. They occur because multiple activities interact unexpectedly. This section focuses on how HSE personnel manage those interactions professionally. As projects become larger, coordination becomes more important than individual task control. The challenge is no longer managing one worker. The challenge becomes managing hundreds of workers performing multiple activities simultaneously. That is where contractor management and visitor control become essential. Contractor control. Contractors perform a significant percentage of work across construction and energy industries. However, before any contractor begins work, organizations must verify competency. This process is known as contractor pre-qualification. Pre-qualification helps determine whether a contractor possesses adequate training, competent supervision, suitable equipment, insurance coverage, safety procedures, incident reporting systems, regulatory compliance history. The objective is simple: prevent unsuitable contractors from entering the workplace. A poor contractor can introduce significant risk regardless of how strong the client organization may be. Method statements. Contractors should submit method statements before beginning work. A method statement describes the activity, the sequence of work, required equipment, hazards, control measures, emergency arrangements, competency requirements. Method statements support safe execution by ensuring activities are planned before work begins. Remember, unplanned work often creates uncontrolled risk. Supervision ratios. Professional organizations also establish supervision ratios. Examples: 1 supervisor per crew, dedicated fire watch personnel, dedicated lifting supervisors, confined space attendants. The exact ratio depends on project complexity and risk. Effective supervision ensures procedures remain implemented in practice. Real site example: a contractor was awarded a structural steel erection package. During pre-qualification review, auditors identified missing lifting procedures and incomplete training records. The contractor was required to correct deficiencies before mobilization. The review prevented potentially unsafe work from entering the project. Common mistake: awarding contracts solely on cost. The cheapest contractor is not always the safest contractor. Competence must always be considered. Visitor orientation and escort requirements. Not everyone entering a workplace performs operational tasks. Many individuals visit temporarily. Examples include clients, government inspectors, auditors, suppliers, students, media representatives. Visitors may have little understanding of workplace hazards. This makes visitor management essential. Visitor induction. Visitors require simplified induction training. At minimum, visitor orientation should include emergency procedures, PPE requirements, restricted areas, photography restrictions, escort requirements, assembly points, emergency contact information. Visitors should understand enough information to remain safe while on site. Escort rules. Many organizations require visitors to remain under escort. An escort ensures compliance with site rules, protection from hazards, control of access, emergency accountability. Escorts should never assume visitors understand industrial risks. Always communicate expectations clearly. Time limit controls. Some facilities limit visitor duration. Examples include restricted area visits, operational plant tours, confined process areas. The objective is minimizing unnecessary exposure. Real site example. A supplier entered a fabrication yard without escort. He unknowingly walked through a lifting exclusion zone. Fortunately, intervention occurred before exposure to suspended loads. The incident reinforced escort requirements. Common mistake. Treating visitors as low risk because they remain on site briefly. Inexperienced visitors often face greater risk than experienced workers. Access control systems. Access control ensures that only authorized personnel enter designated work areas. Access control may involve security gates, electronic badges, permit systems, biometric systems, visitor logs, authorization lists. The purpose is accountability. Organizations must know who entered, when they entered, where they entered, when they exited. Sign in and sign out. Sign in and sign out system support. Emergency accountability, security management, contractor control, regulatory compliance. During emergencies, accurate attendance records become critical. Without accountability systems, evacuation management becomes significantly more difficult. Permit interface. Access control often integrates with permit-to-work systems. For example, confined space entrance, electrical workers, hot work personnel, radiography crews. Only authorized personnel should gain access once permit requirements have been verified. Real site example. During a shutdown project, electronic access controls prevented an authorized entry into a vessel undergoing confined space maintenance. The system automatically verified training and permit authorization. Common mistake. Allowing informal access because workers are familiar faces. Authorization should always be verified, not assumed. SimOps coordination. One of the most important concepts within contractor management is SimOps. SimOps stands for simultaneous operations. SimOps occurs when multiple activities occur at the same time and location, creating interaction risks. The activities themselves may be safe individually. However, their interaction may introduce additional hazards. This concept is widely recognized within oil and gas industries and referenced in API RP 75 Safety Management Guidance. Examples of SimOps. Examples include welding near fuel transfer operations, excavation near underground utilities, lifting operations above scaffold crews, pressure testing near construction activities, vehicle movements near pedestrian zones, chemical transfers near maintenance work. Each activity affects surrounding operations. Hazard interface. The key challenge in SimOps management is hazard interface. A hazard interface occurs when one activity creates risk for another activity. For example, a crane lift may create falling object risk for nearby workers. Welding may introduce ignition sources near flammable materials. Excavation may affect structural stability for adjacent work. The interaction must be assessed, not just the individual activity. Coordination meetings. Professional organizations conduct coordination meetings before major activities. Topics include work scope, work locations, permit status, interface hazards, emergency arrangements, communication methods, responsible persons. Coordination meetings reduce surprises. Surprises often create incidents. Real site example. During refinery maintenance, welding operations were scheduled adjacent to hydrocarbon transfer activities. SimOps review identified ignition risk. Activities were rescheduled to eliminate overlap. A potentially serious hazard was removed before work began. Common mistake. Evaluating activities individually without considering interaction effects. Always evaluate interfaces. Permit interface management. Permit-to-work systems become more complex when multiple permits operate simultaneously. Consider the following example. Hot work permit, confined space permit, electrical isolation permit. All three may affect one work area. If these permits are not coordinated, conflicting activities may occur. Permit interface management ensures compatibility. Common permit overlaps. Examples include hot work inside confined spaces, electrical isolation during maintenance, Excavation near energized systems. Lifting activities over occupied work areas. Radiography near operational activities. Each permit must consider surrounding work. Verification process. Professional HSE personnel should verify permit validity, permit duration, isolation status, work boundaries, emergency arrangements, affected personnel, permit conflicts. The goal is preventing incompatible activities. Real site example. A contractor planned hot work adjacent to an energized cable route. Permit review identified the conflict. Electrical isolation was completed before welding began. Permit coordination prevented exposure to electrical hazards. Common mistake. Treating permits as paperwork. Permits are risk control systems, not administrative forms. Communication protocols. Coordination becomes impossible without communication. Professional projects establish clear communication protocols. These may include toolbox talks, shift handovers, radio communication, coordination meetings, notice boards, permit briefings, emergency communications, radio etiquette. Effective radio communication should be brief, clear, professional, specific. Avoid unnecessary conversation. Use standardized terminology. Confirm critical messages. Repeat key instructions when necessary. Shift handover. Shift handover is one of the most critical communication activities on site. Information transferred during handover should include ongoing work, permit status, outstanding hazards, equipment status, emergency issues, work restrictions. Incomplete handovers create operational risk. Notice boards. Notice boards provide visual communication. Examples include emergency information, permit status, safety alerts, weather warnings, project updates, inspection findings. Visual communication supports workforce awareness. Real site example. A night shift supervisor failed to communicate incomplete isolation work during handover. The omission delayed operations and increased confusion. The incident highlighted the importance of structured handover processes. Common mistake. Assuming information transfer occurred simply because a meeting took place. Critical information must be verified, not assumed. Practical activity. Managing a welding contractor entry. Arrival verification. HSE officer. Good morning. Before entering the site, I need to verify your training records, certifications, identification, and permit requirements. Contractor. All documents are available. HSE officer. Thank you. We will review them together before site access is approved. Step 2. Toolbox talk. HSE officer. Today's activity involves welding near operational equipment. Key hazards include sparks, heat generation, fire risk, and interaction with nearby personnel. Emergency procedures have been reviewed. Fire extinguishers are available. Work boundaries have been established. Are there any questions before work begins? Permit verification. HSE officer. Please confirm your hot work permit. Contractor. Permit is approved and valid until 1800 hours. HSE officer. Permit verified. Fire watch assigned. Gas testing completed. Work may proceed according to permit requirements. Fire watch briefing. HSE officer. Your responsibility is continuous monitoring for ignition sources during welding activities and for the designated post-work monitoring period. Do not leave your position without relief. Immediately report any signs of fire or abnormal conditions. Monitoring. Conduct routine observations. Conduct routine observations. Verify permit compliance. Confirm housekeeping standards. Ensure exclusion zones remain effective. Verify communication channels remain active. Quick quiz. Question 1. What does SIMOPS mean? Answer. Simultaneous operations. Explanation. SIMOPS refers to multiple activities occurring at the same time where interaction may create additional risk. Question 2. Why are contractor pre-qualification reviews important? Answer. They verify competency, procedures, equipment suitability, and safety performance before work begins. Explanation. Preventing unsuitable contractors from mobilizing reduces project risk. Question 3. Why is shift handover critical? Answer. It ensures important safety information transfers between work teams. Explanation. Incomplete information transfer can create operational and safety hazards. Use practical examples throughout this section. Most learners have observed and tracked the coordination challenges. Encourage discussion about permit conflicts, communication failures, and SimOps hazards from real projects. Emphasize that coordination is often more important than technical expertise alone. Many major incidents occur because work groups fail to communicate effectively. End of Section 3.